Alright, here are the questions to do with growth and decay in nature, right? More of the science questions dealing with doing exponentials and logarithms. So let's look at this. The size p of a small herbivore population at time t, and it's in years, obeys this function. So I'm going to write that equation down. If they have enough food and the predator population stays constant, and it says after how many years will the population reach 2100? Let's just see if we really even understand what this equation is representing. So some vocabulary. A herbivore means it's an animal that only eats plants. A predator is someone who eats the herbivore that helps keep that population down so it can be healthy. So a predator would be eating that animal to keep that population of that animal healthy and low. And then there's an equation. Now, the number in front of E represents the beginning amount. So how many herbivores were there to begin with? 700. And then the end amount, 2100. That's going to be P at T. And 0.14 in the exponent means they're growing at 14%. And it's compounded continuously. So it's growing continuously at that percent, 14%. I want to solve for t to see how many years it will take for that population to increase at that. So step one, we're going to divide by 700. Because it goes in evenly, I'm just going to write the number down, which is 3. Otherwise, I would leave it as a fraction. To get t by itself, I need to write this as a logarithm to undo the exponential. So as a logarithm, it would be 0.4t, 14t. And then the logarithm with the base of e is ln, and then inside is 3. And then the last step to get t by itself is to divide. So in my calculator, I'm going ln 3 divided by 0.14. And that tells me the years, and it says it's around whatever. So it's 7.847 years. So almost in 8 years, that population will triple. All right, let's read the next one. So most of these questions, of course, have to do with growth and decay. If something's increasing or something's decreasing. The population of a country was 26 million in 1984. 10 years later, it was 31 million. And then it gives you a growth equation to use. So A equals, we're using some different letters here, and KT. But this is understand what it means. So 26 really means 26 million. But they didn't put million down, just 26. And it says describe the population of the country after 1984. It says use the fact that 10 years after 84, the population increased by 5 million. So if it increased by 5 million, it's now 31 million. But instead of 31 million, I just put down 31 to keep the units consistent. K is what I'm looking for, which is the growth rate. And then T is 10 years. So can you find the growth rate? And we're just going to leave it as a decimal, not write it as a percent. So to get the exponential by itself, so I can solve it, I'm going to divide by 26. It doesn't go in evenly, so leave it as a fraction. K times 10 is 10k. Write this as a logarithm to solve for k. So the exponent is 10k. The logarithm that has a base of e is ln, and then what goes inside is the number 31 over 26. The last step to get k by itself is to divide by 10. So that's what I'm going to do in my calculator. So I'm going to go ln 31 divided by 26, close the parentheses, and divide that answer by 10. And again, I'm just going to keep that as a decimal. So if I round it, really it's 0.018. The 5 makes it go up 1 if you rounded it. So it's a percent. That means the population is growing at about 1.8%. All right, 32. The number of books in a library increases. And again, it gives you the formula. Just understand if they use different letters that you know what it means. So if I understand this equation, the beginning amount of books is 3,500. It says, how many books will there be after 9 years? So the end amount is what I'm looking for. So that's good news. That means all I have to do is substitute in 9 years for t. There's not an equation to solve for here. It's already done. I'm looking for the end amount. So the end amount's the easiest to find. So it's 3,500 times E, which is my blue button, and then E. blue button and ln. And then in the exponent I have 0.05 times 9. So I'm going to round so it makes sense. There's no decimal books. So 5,489 books, no decimals. So to the whole number, because we're talking about books. That's how many books there'll be in 9 years at that rate. And they're growing at 5% in terms of how many books they're increasing by. All right, number 33. The population of a small country increases according to this equation. So they give me the equation. So I'm going to use it and write it down. T is in years. It says how many people will the country have after 9 years. So again, the end amount is what I'm looking for, which makes this very simple. So wherever there's a T, you plug in 9 and then use your calculator correctly. So in this case, 900,000 times E, and then 0.03 times 9. So they're growing at 3%. They started at 900,000. We're going to round to the whole number, so it's 1,178,968. So no decimals for people, so that's what the population will be in 9 years. Turn the page. '34. Conservationists, those are people that make sure that things in nature are conserved, that they don't become extinct, tagged 90 rabbits in a forest in 1990. In 93, they tagged 180 in the same area. If the rabbit population follows the exponential law, and the exponential law is really PERT, but in science we usually go y equals ne to the kt. Same formula, but that's usually the one that we use the most often with those letters. And it says how many rabbits will be there 5 years from 1990. So let's start at the beginning. N is the original amount of rabbits. That's 90. And 3 years later, there's 180. And so the first thing I'm trying to find is what the growth rate is. So 180, the end amount, 3 for the number of years. I want to find K to begin with. So to find K, step 1, I'm going to divide by 90. 180 divided by 90 goes in evenly, so I just write what that number is. To solve for K, I write this exponentially. Oh, it is exponential, right, as a logarithm. So the logarithm with a base of e is ln, and 2 goes inside. The last step to get K by itself is to divide by 3, and then use your calculator. So we have ln 2 divided by 3. Oop, I didn't mean that. So the growth rate, I'll round to 3 decimal places, is 0.231. Now, again, we need to write y equals ne to the kt. So this has 2 steps to it. The beginning population, again, is 90. We now know what rate they're growing at, which is 0.231. And then it says 5 years from 1990. So if we put in 5, that's going to give me how many rabbits there'll be in 5 years. So in this case, we have to find the growth rate first and then use the growth rate to answer the question we're looking for. So 90e to the exponent 0.231 times 5. Again, we're going to round to a whole number. So that's about 286 rabbits in 5 years. So they started at 90 and it grew to 286 using that growth rate of about 23%. 35. How long will the population of a certain country double if its annual growth rate is that? Well, annual growth rate, we know, think of it as money, where n is equal to 1. So any 2 numbers will work that double. So if you have 1 person and you double it, that will work. We don't know the rate is 0.62, so that's 0.062, so we do know the rate. Once a year, that's annual, but we don't know t. So let's simplify this a bit. So 1 times this doesn't change anything. 0.062 divided by 1 is 0.062. When I add 1 to it, it just goes in front of the decimal. and then 1 times t is t. I want to solve that exponential equation, undo it using a logarithm. So the exponent is t, the logarithm has a base of 1.062, and inside the logarithm is 2. To put that in my calculator, I change its base, so the log of the top divided by the log of the base, or log of inside over the log of the base, and then use your calculator. So log 2, try it again. So log 2 divided by log 1.062, and it says to the nearest year. So the nearest year would actually be 12 years. So how many years will that population double? And the answer is 12 years. All right, 36. At any time, of course, you can try it, annotate it, write the equation down, solve it before I do it, or we can work together. If the population of a certain country doubles again in 8.25 years, find the growth rate, K. Assume the population increases exponentially. So that's this formula, y equals NE to the KT, and then round to the nearest tenth of a percent. So if it doubles, the beginning amount is 1, and it doubles to 2. K is what I'm looking for, and it says in 8.25 years. So 1 times E doesn't change E to anything, so I don't need the 1 in front. And this is 8.25K. To solve it, we write it as a logarithm. So the exponent is 8.25K. The logarithm is a natural logarithm base E, and then inside it is 2. And then the last step to get K by itself is we divide. So it's ln 2 divided by 8.25. And then solve it. So the growth rate, it says to the nearest tenth of a percent. So I need to move that decimal 2 to the right. So if I move that decimal 2 to the right, I get 8.4%. So you have to move, look at the number in the calculator and move the decimal 2 to the right. 37. There are currently 59 million cars in a certain country. It's decreasing at 0.9% annually. How many years will it take for this country to have 33 million cars? So great question, right? Because it's an annual percent, we're going to use this formula. So I don't need million. The number in front is fine. So we started with 59. We ended with 33 million. Now here's a good point. The interest rate is actually decreasing. So we actually put in a negative 0.0. Now it's 0.9, right? So it's 0.009. So you got to move the decimal 2 to the left. So that's why it's 0.009, and it's negative because it's decreasing. And then annual means 1, and then T is what I'm looking for. So let's clean this up a bit. We're going to divide by 59. When I go negative 0.009 divided by 1, it's 1. So basically, it's a little bit tricky. Go 1, subtract 0.009. It's nice to have a number. Just add a number inside as a base. So that's going to be 0.991, and that's to the exponent t. To get t by itself, we're going to write it as a logarithm. So the logarithm is going to have a base 0.991, and inside it's 33 over 59. We're going to change the base. That's the log of what's inside divided by the log of the base. Now we're going to put that in our calculator. So log 33 divided by 59 divided by log 0.991. And it gives me the answer 64, and it says to the nearest year. So it's about 64 years. That's how many years it would take to decrease the number of vehicles. 38. There are currently 68 million cars in a certain country, increasing exponentially by 1.4%. How many years will it take? So exponentially, I'm going to use this y equals NE to the KT. it started with 68 million. They're going to end with 80 million. The interest rate here, 0.014, and then T is what I'm looking for. I know it's a little confusing because it says exponentially and the word annually, so they're kind of counter words, but use the exponential model. And now we're going to solve for T. So step 1, we're going to divide by 68. Step 2, we're going to write it as a logarithm. So the exponent, 0.014t, and then the logarithm is a natural logarithm. What goes inside it is 80 divided by 68. The last step to get t by itself is to take that natural logarithm, the ln of 80 divided by 68, and divide that by 0.014. So that's what I'm going to do right now. So ln 80 divided by 68 and divide that by 0.014. And how many years approximately? And it says round to the nearest year, so that would be 12 years. That's how many years it would take for them to get 80 million cars. All right, the half-life of silicon is 710 years. If 60 grams is present now, how much will be present in 900 years? So some keywords, 710 years in half-life. We're going to start there. So half-life follows this exponential model, y equals ne to the kt. Half means if you start with 2, half of the size would be 1. That's half-life. And then we're looking for the rate it's decreasing at, so the k is going to be negative when I solve it, and then t, the year, is 710. So to get e by itself, I'm going to divide by 2, so there you get the 1/2, half-life. They're always going to match that way for half-life. And then in the exponent, I have 710 times k. I want to solve for k by writing it as a logarithm. So write down the exponent. The logarithm of the base of e is ln, and what goes inside it is 1/2. To get k by itself, you divide it by 710. So I'm going to use my calculator, ln, and then make sure you close your parentheses. Don't put 710 inside the logarithm. Remember I said we're going to get a negative answer. Now what's interesting here is, do you see how my calculator gave me scientific notation? So that means I need to move the decimal 4 to the left. So I move it 1 to the left, and there's going to be 3 zeros in front of 9. I'm going to keep a bunch of decimal points to try to be as accurate as possible. The more decimal points you keep, the more accurate the answer is going to be. So I'm going to write down y equals ne to the kt again, and now I answer the next part. So the beginning amount is 60. The end amount, I don't know, right? That's how much I'm looking for. How much will be present? So I don't know the end amount. The decay rate is negative 0.00097,626, and the number of years is 900. So that's what I'm going to put in my calculator. I don't need to solve for anything. Just be careful that you type it into the calculator correctly. So I'm going to type in 60 E. That's negative 0.00097,626 times 900. And so how many grams remain? To 3 decimal places, so 24.921. And the answer is in grams. So approximately 24.921 grams would remain in 900 years. All right, turn the page. 40. The half-life of plutonium is 9 hours. So I'm going to start there, just that. So I write down y equals ne to the kt. That's the formula we use for half-life. We know that if you start with 2 and half of it is 1, that we can use that as a model to find the decay rate, and it takes 9 hours to do it. So be careful the unit of time. To get e by itself, I divide by 2, and then I'm going to write this as a logarithm. So the exponent is 9k, the logarithm with a base of e is ln, and inside is 1/2. To get k by itself, it's ln 1/2 divided by 9. So I can use that in my calculator. I'm actually going to show you another way so it can be really accurate. Let's not write that as a decimal. Just when it's k, I'm going to put that exactly in when I put it in my calculator. Alright, so now I know and this is going to be the decay rate. I write down y equals ne to the kt again. Now I read the next sentence. So we start with 50, and then it says how much will be present. So the end amount is what I'm looking for. I already know what to put in when I say k, and then the number of years or days is 6. Now be careful here, and the reason is that you have hours and then days. So in order for this to work, we found the rate in terms of hours. So on the side, I need to know that 6 days is equal to 6 times 24 hours. So how many hours that is? That's 144 hours. That's how many hours 6 days is. So when I plug it in, I need to plug in 144. Remember, this k is going to go in here. So when I plug it into my calculator, it's going to be 50e, and then in the exponent it's going to be ln 1/2 divided by 9, and then take that answer times 144. All right. So 50e, I said in the exponent we have ln 1/2 divided by 9, and then we're going to take that answer times 0.14. Let's try that again. Let's try this way. So 50, I think if I change the parentheses here, so again, I'm going to use ln 1/2 divided by 9. But I'm going to insert a parentheses here. So that's what, oops, all right, move back here. So that ln 1/2 divided by 9 is what k is, and then I take that answer times 0.14, not 0.1, see that was my mistake, just times 144. Now you can see a difference. Because I put a decimal in before, that was my problem. Just 144. See, that dot made me think it was a decimal. Hey, I'm on track now. There's not much left. That's the whole point. Do you see the scientific notation left? You take the decimal. What number do I move it to the left? So I move it 4. So 1, and then how many zeros would be in front of 7? Right? Like so little. That's how many, and it's in milligrams. I mean, so little would be left in 9 days because it's decaying so quickly. You could also write this as 7.629 times 10 to the negative 4. Have you ever done that in milligrams? Have you ever written a number in scientific notation? So that would be the scientific notation. Same answer, just written in a different way. All right, 41. The function a equals a sub 0, e to the exponent negative 0.008666x models the amount of pounds of a particular radioactive material stored in a concrete vault, where x is the number of years since the material was put into the vault. If 500 pounds of material are initially put into the vault. So a sub 0 is a way to say the initial amount of, that you have. That's that sub 0, initial, times 0. That's 500 pounds. And it says how many pounds will be left after 30 years. So this is the end amount, what I'm looking for. And so I'm going to use this. It decays at this rate. And then x is going to be 30. and that's what I put in the calculator. So 500 E, and then negative 0.00866 times 30. And it said round, so I'll just round myself, 385.603 in its pounds. So that's how much will be left after 30 years, decaying at that rate. 42. You have another function, same idea, models the amount of pounds, again in a concrete vault. So same kind of question. So I start and practice it over again. The decay rate's a little different. It asks the same thing. This time you start with 400 pounds. So that's the initial amount. And then it will ask something actually different. So we need to figure out, this case it gives you the end amount, which is 89 pounds, and it says how much time. In this case, x represents the time. So now let's solve this equation, solving for x. So step 1 is to divide by 400. Step 2 is to solve by x by writing it as a logarithm. So to do that, I'm going to write down negative 0.01155x, and the logarithm is going to have a base of e, so it's not log but ln because of that. And then inside the logarithm's 89 divided by 400. To get x by itself, we're going to divide. So we have ln 89 over 400 divided by negative 0.01155. So that's what I'm going to put in my calculator. That will tell me how many years it would take to decay to that rate. So ln 89 divided by 400 divided by negative 0.01155. So it's about 130.115 years. So about 130 years. It'll start at 400 pounds and decrease to 89 pounds. That's how many years it would take. All right, turn the page, last page. 43. An endangered species of fish has a population that is decreasing exponentially. So they give you that. We know that even better is y equals ne to the kt. That's fine, write that down. The population 8 years ago was 1,900. Today you only have 1,000 that are alive. Once the population drops below 100, the situation will be irreversible. So when will this happen? So that irreversible, I mean, once it's below 100, the fish will no longer exist. They can't repopulate itself, and it will die out. So to answer this, we're going to start with, we start with 1,900 fish. We can't get below 100, so we need to know how long it will take to get to 100. And it says, when will this happen? Oh, let's start again from the beginning. So let's use 1,900 and 1,000. We first have to find the rate they're decaying at. So we start with y equals ne to the kt. The beginning amount was 1,900. We went down to 1,000. How many years did it take to get to 1,000? And the answer was 8 years. So now we're going to solve for k, the decay rate. So first we're going to divide by 1,900. We're going to solve for k by writing it as a logarithm. So 8k is equal to the natural ln of 1,000 divided by 1,900. And then the last step is we're going to divide by 8. So I'm just going to write it as a decimal and then use that number for the next step. So ln 1,000 divided by 1,900 divided by 8. So it's negative because it's decreasing. So I'm just going to use this number right here. The more decimals you keep, the more accurate the answer is going to be. So now I can do what I was trying to do before. So you have y equals ne to the kt again. Now the beginning amount is, well, right now we have how many, right? Right now, today you only have 1,000 fish. So how long until it gets down to 100? And it's decaying at that rate, negative 0.080231. And I'm solving for t to see when that time will happen. So to get e by itself, I'm going to divide. So I have 100 divided by 1,000. To get t by itself, we're going to write it as a logarithm. So it's a natural logarithm. And then the last step, we're going to divide. So I'm going to put that up here. So the answer is ln 100 divided by 1,000 divided by that number, negative 0.080231. All right, let me put that in the calculator. So 100 divided by 1,000, and then that answer divided by negative 0.080231. So in how many years will it be irreversible? So in about, and it says round to the nearest whole year, so in about 29 years. So in about 29 years, that fish will go extinct, declining at that rate. 44. A sample of 550 grams of radioactive substance decays according to this equation. So I'm going to write that down. So it already gives you the decay rate, so I don't need to solve for it. And we started with 550 grams, so you can see where that is. It says how much of the substance will be left in the sample after 10 years. So I'm looking for the end amount, so that's the easiest way question we could be asked. Plug in 10 for 10 t for 10 years, and then just use your calculator. And into the nearest whole gram, it's 336 grams. So in 10 years, that's how much would be left of that radioactive substance. 45. How long will it take a sample of radioactive substance, feels like Spider-Man, doesn't it, to decay to half of its original amount if it decays according to this model? So again, it gives me the equation to use, which means I don't need to solve for the decay rate. It gives me the decay rate. That's the easiest situation. And it says round to the nearest 100. So how long will it take it to decay to half of its original size? So 300, half the original size would be 150. It's just half the number. And now I need to solve for t. So to solve for t, I'm going to divide by 300. I'm going to write it as a logarithm. So it's going to be negative 0.054 t. The logarithm of the base of e is ln, and then inside is 150 divided by 300. To get t by itself, we divide. And we divide by negative 0.054. That's it. So we have ln 150 divided by 300 divided by negative 0.054. So how many years? And it says, does it say how to round? To the nearest hundredth of a year. So that's two numbers after the decimals. That's 12.84 years. So how long would it take to become half its original size using this model? 12.84 years. All right, last one. I'm so proud of you. You got to 46. Hooray. Last one. Let's practice the last one together. A certain radioactive isotope decays at a rate of 0.275% annually. Determine the half-life of this isotope to the nearest year. So half-life, I know it says annually, but we're going to still use y equals ne to the kt. Half-life means you start with 2 and you end with 1. So if they don't give you the amount, you just start with two numbers that are half of each other. K, we said, is decays, so it's negative point. And then we're going to write it as a decimal. So we have to move the decimal, 0.00275. And then what I'm looking for is t, which would give me the half-life. How many years would it take to become half its size? To get the exponential by itself, divide by 2. To solve for t, we write it as a logarithm. So the exponent, negative 0.00275t on one side. The logarithm's ln, and inside is 1/2. And then the last step to get t by itself is to divide. So it's ln 1/2 divided by negative 0.00275. And now use your calculator. So I'm going to go ln 1/2 divided by negative 0.00275. And it says round to the nearest year. So that would be 252 years. So the question is, what is the half-life of this isotope? And the answer is the half-life is 252 years. That means it takes 252 years to become half its size as it's decaying. You got to the end. I'm so proud of you. All right, Mr. G Math, over now.